Good day everyone. Today I am going to discuss about the load characteristic curve. In this video, the no load saturation as well as the zero power factor curves are significantly involved. And I believe both of these topics were already discussed by other reporters. So, on the other hand, under this topic, the load characteristic curves, we will explore two different processes, claiming that the no-load saturation curve as well as the zero power factor curves are both assigned as given for the two cases. So it is said that the zero power factor saturation curve under consideration is only one special case of load characteristic curves. So by looking at the diagram, we can see the load characteristics at various power factors. So we can notice that they all pass through the same lower point, which corresponds to zero terminal volts at full load current. And this is obtained only by short-circuiting the armature terminals. Moving on, as I have said earlier, we have two processes or methods under load characteristic curves, claiming that the no-load saturation curve as well as the zero power factor curves are both assigned as given for the two cases. So, for the case 1, we need to obtain load characteristics at any power factor. For the case 2, we need to obtain zero power factor curve at any other current. For the case 1, in order to obtain the load characteristic curve at any power factor, we need to consider the following steps. And by looking at the diagram, the first thing we can do is to calculate the armature resistance drop per phase. It is not necessary to calculate the armature resistance drop per phase at all times. So it depends upon its magnitude with the reference to the synchronous reactance drop PA as shown in the diagram. For the second and third step under case 1, with reference to the shown figure, by using O as the reference point, we need to draw the IR sub C drop, making desired power factor angle with the horizontal. And then, we need to draw the synchronous reactance drop, which is I X sub S equals AP, thereby locating the point A. And for the last step under case 1, with reference to the shown figure in the presentation, we need to draw AS from A to the base. This fixes the value of terminal voltage SO, which would result to the given power factor. With this in mind, by this process, which simply consists in calculating regulation diagrams in reverse, the several load characteristic curves are obtained. For the second case, in order for us to obtain a zero power factor curve at any other current, the following procedure is suggested. And by looking at the diagram, we can notice that the altitude of the polarizer triangle and the base FP are both proportional to the current. Hence, we can see that for the half current, neglecting saturation effects on the two components, the polarizer triangle reduces to half size. Therefore, if a triangle of a size proportional to the change in current is moved along the no-load saturation curve so that the point Q remains on the curve and the base remains horizontal, the new point P will trace the zero power factor curve for the required load current. To summarize, under this topic, the load characteristic curves, there are two processes or methods to consider. And by following the given steps, we can now obtain the load characteristic at any other power factor as well as the zero power factor curve at any other current. So this is the end of my presentation and thank you for listening.